So like see how these ripples, these are two black holes, when they collide, so then waves would be generated. Now can you see the ripples? So how these ripples would be generated? This is how they will be repeated, they will be generated. So see, this is one light source, this is another light source. So light would be grabbed from this one, light would be grabbed from this one, and here interferometers would be there. These interferometers, what they will do, they will merge the two light sources and they will decode, they will frame it into a kind of decodable things, so that we can study them. And in this, if gravitational waves are there, we can observe when gravitational waves have been produced. So that's how. So they will split the light into some readable form, so that identifiable form, so that they will be observed. So that's how this LIGO project will work. Okay. So that is one thing. So for your purpose, try to go through and read these things which are in news. Like it can be Chandrayaan-3 mission, Aditya L1 mission, Gaganyaan mission. So in Gaganyaan mission, read things related to, have you heard about Vyom Mitra? Vyom Mitra? What is Vyom Mitra? Good. So in simple fashion to say, it's basically a robot. Okay, robot. So what kind of robot? Is it an android robot or gynoid robot? What do you mean by android, or what do you mean by gynoid? See, android. Android means which resembles like a man. Gynoid. Gynoid means which resembles like a woman. Are you getting that? In robots, we will have two kinds of robots based on their appearance. Android robots means those robots which resemble like man. Gynoid. Gynec, have you heard about gynec? Gynecology, gynec, all those things. So gynoid means it when it resembles like a woman. Like Vyomamitra is a half humanoid gynoid robot. Half humanoid. Humanoid robot means which resembles like a man, which resembles like a human being. So Vyomamitra is a half humanoid gynoid robot. That means till you might have saw it in images. So till the west portion, this robot would be there. Okay, so you see, it is not entire standing robot. So see, this is Vyomamitra. So can you see, till half only this robot would be there. So that's why it is half humanoid, because it is looking like human being, and particularly it's a half humanoid gynoid type of robot. So this Vyomamitra will be accompanying the astronauts. Okay, so usually like we have planned to send four people. It would be first human space flight mission by India. So that is one thing. So let's try to just let's learn more about such kind of things. So but you go through such things. Okay, so okay, so that is one thing. So then with respect to LIGO, we'll learn more with respect to LIGO. Then Project Netra. Have you heard about Project Netra? Project Netra? Yes, it is a project related to space debris, detection of the space debris. Okay, so just when you see in questions also, you might have got question on Netra. So have you gone through that? Have you solved the questions? So Project Netra. So Network for Space Object Tracking and Analysis. That is Netra. Network for Space Object Tracking and Analysis. Okay. So what is the chief thing? It is initiated, ISRO's initiative. So thing is that it is to detect the space debris. Okay. And other hazards to Indian satellites. So usually now you assume what is space debris means. Now we are from the Earth, we are sending a lot of satellites to space. Okay, and there would be certain amount of fuel for that satellites, and after certain time, this becomes non-functional. Okay, we have to decommission it. So after after it becomes dysfunctional, so then obviously we cannot bring it back. How would we bring back those satellites we have sent? So that becomes debris, that becomes a waste material that would be circulating or rotating in the space. So this becomes space debris, that means which is not useful. So this space debris sometimes may become an issue where it may, like for example, sometimes it may hit the other satellites or likewise. So this is a project launched by US to detect such kind of debris in the space, and if there is any such space debris posing any hazardous threats to Indian satellites, that will try to track such kind of things. Okay, so that is Project Netra. So you remember, Network for Space Object and Tracking and Analysis. Okay, so I hope you might have solved these questions. Okay, so read such kind of things like Anita. There is Anita. So Anita is Antarctic Impulsive Transient Antenna. Okay, so Antarctic Impulsive Transient Antenna. So it's a kind of experiment which is a kind of telescope. Okay, so antenna, which is a kind of first observatory for observing some neutrinos likewise. Okay, so just go through. It's a radio telescope. Okay, so remember, Anita is a radio telescope. Its chief purpose is neutrino observation. So just go through such kind of things. Okay, so just to go through them, and we'll just see some things like Yarkovsky effect. So Yarkovsky effect. So it is another type of important kind of things or questions that can be picked and asked. Okay. So what is Yarkovsky effect means? Usually we will have some celestial bodies, let's say like asteroids. Okay. So if we see what is Yarkovsky effect, so like actually it is a minuscule push on a small body like asteroid in the space impacted by sunlight. So usually sunlight, when it is coming from sun towards the space, so it gives a kind of minuscule push to the celestial bodies like asteroids. Okay, so this minuscule push creates a rotating effect for the asteroids. So that effect created by the minuscule push impacted by the sunlight, so that effect is known as Yarkovsky effect. Okay, so can you able to understand that? So I'll remember, imagine there is an asteroid and imagine sunlight is coming from the sun, and when the sunlight comes and when it touches this asteroid, due to the force, there would be a minuscule push. We are saying minuscule means it would be very minute push would be there. That push, that effect, we are calling it as Yarkovsky's effect. Okay, so that is that through this what will happen, the asteroid's orbit will keep on changing. Okay, so but it takes a lot of years time, but continuous and constant push will make this asteroid to shift in its orbit. Okay, every rotating orbit will have object will have a curved path. So if it is pushed slightly like this, like assume this is rotating like this, if it is pushed like this, then orbit may change. So what will happen? An asteroid orbit has been disturbed, will be disturbed generally by that kind of heat or by that kind of sunlight. So that is how that effect is known as Yarkovsky's effect. Okay, so go through such kind of things. So we'll see further important aspects from. Yes. Pardon? Not audible. Yarkovsky's. Okay. So shall I repeat the concept? You mean to say? Yes. Okay. So simply, See, there can be an asteroid. And this asteroid might have an orbit like this. So it might be rotating around a larger object, a larger orbit, larger object, celestial body. So take any other large celestial body like Earth. So usually this could be the orbit, natural or normal orbit of this asteroid. Okay. Now, what may happen due to sun? Assume that this is the sun. Due to the sunlight, assume that sunlight is coming and hitting this asteroid. So due to this, now instead of having this this orbit, due to minuscule push, the sunlight will give minuscule push. That means there would be a heat generated from this sunlight. So this heat makes it to have a slight shift in its position. So when its position has got shifted, so its orbit also slightly gets shifted. Then this becomes the altered orbit. Are you getting that? But this will happen in a very at a very minuscule level. So that's why it would be very we cannot understand this generally, but simply notice this clearly generally. But this will happen on long run. So orbits, asteroids orbit will change due to this push given by the sunlight or heat generated by the sunlight. So effect is that it will change its orbit on long run. That will happen. So that kind of effect of change in the position, change in the path of this asteroid is known as Yarkovsky effect.
It only affects
Asteroid. Asteroids. We will have small objects like asteroids. It's not for planets. Okay. Generally, it is said from the perspective of asteroids. Okay. So we have so many asteroids. What about that? Here, when you talk from the perspective of artificial satellites, when we are sending them from Earth to the space, we will have a lot of calculations and we will check the exact centripetal force, we will check the orbital velocity so that this path will not be changed. This path would be fixed. So we will calculate everything and with this calculations only we will set. So there won't have any issue of the Yarkovsky effect for the artificial satellites because everything is well calculated and well planned and in a scientific manner we will be sending. But asteroids are natural objects. They don't have such kind of natural mechanism to withstand that. And you see for artificial satellite there would be fuel which would be helping it to hold in the same position, hold in the same particular force would be generated and it will match up with that orbital force. So for artificial satellites there won't be any effect. These are natural things. So asteroid would be a natural satellite. Yes.
It is only applicable to those asteroids which are asteroid belts, or it could be of anywhere.
Anywhere in asteroid belt, anywhere also. Asteroids simply, that is like if you see if they are nearer to sun, there would be more effect. If they are like let's say for example an asteroid belt in between Mars and Jupiter if we are talking. So in asteroid belt it is more likely that they would be affected. Are you getting that? If you go like for example if you go near to Neptune and all those things, there is less force, less sunlight would be reaching them and effect would be less, obviously. Like similar way, nearer more would be the effect, farther less would be the effect. Same as the same logic.